Today we're going to review some pre-calc material, composition, domain and range, and lines. So let's start with composition. F composed with g of x can be written with this hollow circle there, but the notation I like more is f of g of x. Means do g first, then f. So let's look at an example here where I've got an f and a g, and I want f of g of x to begin with. So that's f of, now I'm going to put in g, 1 over x plus 1. Now f says, take what's in the parentheses, multiply it by 2, and then subtract 1. Okay, well, that's 2 over x plus 1 minus 1, but I'm going to write 1 as x plus 1 over x plus 1, so I have a common denominator and I can combine fractions. So I'll get negative x on the top, and then 2 minus 1 is plus 1, and then on the bottom I have x plus 1, and that's fully reduced. Okay, you should pause the video and see if you can do the other two, completely simplify. Okay, hopefully you did that. So here I'm changing up notations. I've already written it as g of f of x. So this is g of, and f is 2x minus 1. And then g says, take whatever in the parentheses, put it in the denominator, and add 1. So this one's super easy. It's just 1 over 2x. Okay, last one, g composed with g. So I want to do g to 1 over x plus 1. Now g says, take whatever in the parentheses, put it in the denominator, and add 1. All right, this is a complex fraction. In this case, if I multiply this whole fraction by x plus 1 over x plus 1, I'm just multiplying by 1, so that's okay. And what I'm going to get on top is x plus 1. And on the bottom, I have to distribute this x plus 1 to both this fraction and this 1. So when I distribute it to the fraction, I just get 1. That was the point. I'm going to clear denominators. And when I distribute it to the 1, I just get x plus 1. And so that gives me x plus 1 over x plus 2. All right. If I'm going too fast, you can use that gear key to slow me down. And if I'm going too slow, you can use the gear key to speed me up. Domains. The domain of a function is the set of values where the function is defined. So typically we're going to find problems with 3 types of functions. If we have a fraction, you can't divide by 0. So the domain will be the set of all x such that the denominator is not equal to 0. For square roots, can't take the square root or any even root of a negative number. So we're going to take what's underneath the square root sign, that's called the argument, and set it greater than or equal to 0. And those values will be the values in the domain. Logarithms are super similar to square roots, except that you have to set the argument strictly greater than 0 because you cannot take the log of 0. You can take the square root of 0. You can't take a logarithm of 0. All right, so I'm going to do 3 examples, one of each one. So the first one, find the domain of this rational function. I have to factor the denominator to see where it's 0. That factors as x minus 3, x plus 2. Okay, so the domain in inequality notation would be all x except 3 and negative 2. So I'm going to write that as x not equal to 3 or negative 2. And in interval notation, a quick way to get interval notation if you're not too good with that is plot these values here on a number line. Here's negative 2, and here's 3. The domain is all the x's except those. So I want this interval, and this interval. So in interval notation, this would be negative infinity up to negative 2, union negative 2 up to 3, union 3 to infinity. It's much quicker to do inequality notation for a rational function. All right, next one, find the domain of this square root function. And so first thing we want to do for the domain, we take the argument out and set it greater than or equal to 0. So that would be x greater than or equal to 3. That's inequality notation because it's an inequality. In interval notation, that would be 3 with a square bracket indicating we want to include 3 up to infinity. That's interval notation. All right, let's graph that to find the range. The square root function looks like this. And so if I subtract 3 underneath the radical, that's just a horizontal shift, 3 units to the right. So my graph looks like that. And I can determine the range from that graph. The range is the set of y values that the function takes on. So that's going to be y greater than or equal to 0. Okay, and here's a logarithm one. For the domain, I need the argument x squared plus 1 greater than 0. Not greater than or equal to, strictly greater than. So that's x squared greater than -1. Well, that's always true. The smallest x squared could be is 0. And so x squared will always be bigger than -1. So the domain is all x. Okay, quick review on lines. I've got the slope formula here for you for a line passing through 2 points. Just remember, rise over run. There are 2 special cases with slope. If the x coordinates are equal, then in the denominator of this slope formula, you're dividing by 0. So that would be an undefined slope. And if the x coordinates are equal, that's going to give you a vertical line. Conversely, if the y coordinates are equal, then in the numerator, you're getting 0, the numerator of the slope formula. 0 in the numerator gives you a 0 slope, and you've got a horizontal line. All right. For parallel and perpendicular lines of slopes m1 and m2 respectively, parallel lines have equal slope. Perpendicular lines have a slope that's related by negative reciprocal. That's as long as m2 is not 0. All right, and then the equations for lines that you should know by heart. Slope intercept, y equals mx plus b. M is the slope, b is the y-intercept. Point slope, y minus y naught is m times x minus x naught, where x naught, y naught is any point on the line, and m is the slope. A horizontal line through AB. So let's draw a line horizontal through AB. All right, so you can see on that line, the y coordinate is always b. X can be anything. So this is y equals b. If it's a vertical line through AB, then the x coordinate is always a, and y can be anything. So let's do an example. Find the point slope and slope intercept forms of the line through this point and perpendicular to this line. All right, we've got our x naught, y naught. So the first thing we need to do is find the slope of this line. So to do that, let's put it in slope intercept form. -8y equals -4x plus 1. Divide by -8, y equals 1/2 x minus 1/8. So this line has slope 1/2. So we want to use m equal negative the reciprocal. -1/2 is -2. So now I've got my x naught, y naught, and I've got my m. So I can put it together in point slope, and I get y minus -2/3, which I'll write just as y plus 2/3 equals -2 parentheses x minus 1/2. There's my point slope. And for slope intercept, what I do is I solve for y. And so this will give me y equals, distribute the -2, -2x plus 1, and then subtract 2/3 from both sides, and then clean that up. Y equals, so this implies, you don't want an equals there, don't want a string of equals, y equals -2x plus 1/3. Now these problems are going to be important because in calculus we'll be finding equations of tangent lines, and typically we'll have to go through point slope and then go to slope intercept. So knowing both of these equations is important. All right, finally, the difference quotient. Again, this is going to be important for us in calculus because this is the way we're going to define derivatives. So let's find the difference quotient for this function here. So I'll write difference quotient, dq, is equal to, all right, I want f of x plus h. This is the difference quotient up here. And I'm going to apply that to this f. So f of x plus h is 2x plus h quantity squared minus 3x plus h. And then I want to subtract f of x. use parentheses, 2x squared minus 3x. And that's all on top, and on the bottom is h. And I want to see you carry along the h on the bottom until the end, even though you're just going to be simplifying on the top along the way. So on the top, we need to use FOIL on this x plus h squared. So 2x squared plus 2xh plus h squared. And now I'll distribute the negative 3x minus 3h, and I'll distribute the negative 1, negative 2x squared plus 3x, all over h. All right, this 3x cancels with that one, and I need to distribute this 2. So this is 2x squared plus 4xh plus 2h squared minus 3h minus 2x squared, all over h. All right, now this 2x squared cancels with that one, and the 3 terms left on the top all have an h in them. So this equals, factor the h out. Please don't put arrow here, a single arrow. When you want equals, write equals. Arrow is not correct. So this equals 4x plus 2h minus 3 times h on the top, and then I've got an h on the bottom. Now I can cancel because I'm canceling from a product. Cancel those h's, and I get 4x plus 2h minus 3. And there's my answer. Okay, that's the end of what I'm going to do with you. And then on your own, I want you to do these problems on simplifying exponents. They're incredibly important, and we'll use them when we find derivatives. And the answers are at the end, so you can check your solutions. And that is the end of this section.